All four datasets have been downloaded and added to QGIS. So I'll take a moment to familiarize myself with the data and what information it contains. And as with any project, I'll have to do some data preparation to make sure the data are appropriate for the analysis. First off, let's organize these data layers. QGIS has put them in what appears to be alphabetical order, and I want typically point layers to fall on top of line layers to fall on top of polygon layers. So I'll drag the monuments layer to the top of table of contents. I'll then grab the road inventory layer and drag that above the census tracts. There seems to be some issue going on with the data. These data sets are falling together, and I can see the Bernalillo monuments falling far to the southwest, which leads me to believe there may be an issue going on with the coordinate reference systems here. To begin exploring this issue, let's right-click on the Bernalillo monuments layer and zoom to layer extent. And now I can see that they're actually falling well with the census tracts, but these two data sets seem to be falling quite a bit away from the other two. I'll click the Zoom to Previous Extent button. So let's investigate the coordinate reference system of each layer. I'll start with jurisdiction. I'll double click it to open the layer properties and go to the General tab. Under the coordinate reference system, I can see that it's a Mercator projection. And knowing some things about state plane and the data that comes from the city of Albuquerque, I know this is in state plane New Mexico Central. That state plane zone uses the transverse Mercator coordinate system. So this data set is in New Mexico State Plane Central. I'll open up layer properties for the census tracts. This is in geographic, WGS 84. Look at the road inventory. This too is in State Plane, New Mexico Central, which makes sense. It comes from the county. And typically counties and municipalities will put their data in State Plane. Lastly, I'll check out the monuments. And they're in a geographic coordinate system too, NAD 83. Next, I'll open the project properties and go to the CRS tab. One thing I can do right away to start to fix the problem is enable on-the-fly CRS transformation. And while I'm here, I'll set the coordinate system for the project to New Mexico Central State Plane and click Apply. Now I can see that all the data layers are falling on top of one another. The map is in State Plane, New Mexico Central, and that means the two layers that are not in that coordinate system, the monuments and the census tracts, are both being reprojected on the fly into State Plane from their native geographic coordinate system. I can use the zoom button to zoom into the data so that I can see them a little bit better now. Projecting on the fly is fine for cartographic purposes. However, when we're conducting a geospatial analysis, all the data layers involved should be in the same coordinate reference system. Typically, data layers will also be clipped to the extent of the study area to reduce rendering and data processing time. These kinds of procedures are often referred to as normalizing your data. For the typical analysis, most of the time is spent obtaining data and normalizing it. Once all the data is organized and normalized, the analysis is often very straightforward. I'll want to put all four layers into the same New Mexico State Plane Central coordinate system for this analysis. So I need to reproject both the monuments and the census tracts into New Mexico State Plane Central. I'll start with the monuments layer. I'll right click on it and I'll choose Save As. I'm going to browse to the My Data folder and call this data set Burn spcs.shape. It's useful to have a naming convention for new data layers. Here I'm including the coordinate reference system in the name of the new shapefile. Next, I'll need to choose the coordinate reference system for the new copy of the data. I'm going to look at my recently used coordinate systems and find the New Mexico State Plane Central coordinate system listed there and choose it from that list. I'll click Add Saved File to the map and click OK. My new layer is now shown at the top of the table of contents, and I can right-click on the original monuments layer and choose Remove. I no longer need it. I can work with the new one in the state plane coordinate system. I'll repeat this procedure for the census tracts. I'll right-click on this layer, choose Save As. I'll browse to the My Data folder. And I'll use the same naming convention. ending the name of this new shapefile with SPCS. I'll again browse for the coordinate system, find New Mexico State Plain Central in my recently used list, click OK, check Add Saved File to Map, and click OK to reproject this layer to a new shapefile. My new layer is added to the table of contents, and again I can right-click on the original and remove it. It was an intermediate data set. For the map, I'll need a polygon that represents the county boundary. The census tracts collectively define that county boundary, so I'll use the dissolve spatial analysis technique to create a county boundary from the census tract polygons. To conduct a dissolve operation, I'll go to the Vector menu, Geoprocessing Tools, Dissolve. My input vector layer will be the census tracts, and here it's asking for a dissolve field. You can dissolve based on attributes. For example, if I had a Counties of the United States layer, I could dissolve them based on the state name attribute and create a state boundaries layer. Here I want to dissolve them all into one polygon, so I'm going to choose Dissolve All instead of choosing an attribute field. I'll click Browse to choose an output shapefile, and I'll call the output BernalilloCounty.shape. Click Save. Be sure to check Add Result to Canvas and click OK. Close the box when it's done, and you can see the Bernalillo County shapefile has been added to the table of contents, and I can now right-click on census tracts and remove that from my table of contents because that again was an intermediate layer that I no longer need. Next, I want to filter the monuments so that I only have the ones with the orders and classes I'm interested in. The surveyors that I'm doing this analysis for were interested in monuments that have an elevation order of 1, that were last recovered on or after 1995, and that satellite observations were used for monument coordinate determination. So to filter this layer, I'll double-click on the layer properties and go to the General tab. And notice there's a section here called Feature Subset. This is where I can define the contents of a layer based on the attributes. And that layer will be filtered just within this map document. I'll click on the Query Builder button. This allows me to create a SQL query to filter the data. And I'll start with the first criteria, elevation order. On the left here, you'll see all the attributes of that data set. I'll scroll down to find elevorder, double click on it to place that field in the filter expression window. When using this query builder, it is best to double click instead of typing into it. You'll notice that there is specific syntax tied to fields and values. Here the field is surrounded with double quotes, and you can avoid a lot of headaches by simply double clicking, allowing the query builder to build the syntax for you. So elevorder I want to equal 1, so I'll use the equal operator. And with elevorder selected, I can choose to get a sample of the values or all the values. And this is useful too because I know I want elevorder 1 and I'm not sure what the syntax might be. So I can simply double click on 1 to have that entered into my expression. And you'll notice that has single ticks around it. Since I want monuments that have both an elevation order of 1 and were last recovered on or after 1995, I'll now use the AND operator. Find it right here, click it, and it enters into the expression. The AND operator selects records that meet conditions on both sides. After the AND operator, I'll create the portion of the expression dealing with the last recovered field. Here's that field here. I'll double click that to enter that into the expression, and I'll get a sample of all the values. I'm interested in those recovered on or after 1995, so I can scroll down through these. I don't see 1995, but I can see 1994, October 12th. I'll use that value combined with the greater than operator. Greater than 1994, 1012. So my expression now reads elevation orders equal to 1 and last recovered since 1994, 1012. Finally, I'll add another AND operator and create the third portion of the expression dealing with the satellite use. Here's the field for satellite use. It just has values of null, no, or yes, and I'm interested in those that were used for monument coordination determination. So I want a yes value. So I'm going to use the equals operator and choose the Y. My expression is now complete. I can click the test button, and I should end up with 47 rows. So that's a good sign that I don't have any syntax errors. If you do have syntax errors, you'd see them here, and you'll have to review your expression to make sure where that error is and remove it and get the syntax correct. Now I can click OK, see the expression entered in the feature subset window, and click OK again. And you'll see the number of monuments greatly reduced. And if I open the attribute table for monuments, I can verify that it did what I expected it to. I can scroll to the right-hand side where these fields are. Here's elev order, and I can see it only contains ones. Here's last recovered, and I can see it has no dates before 1995. And here's the sat use field, and I can see they all have yeses in them. In the next task, you'll learn how to use the buffering and clipping operations to identify monuments within the city limits.